Hello class. Today's lesson will be over 7.6a probability. Please take notes, be prepared for today's lesson. Probability. Probability is the likelihood that an event will occur. Remember, probability is usually expressed as a fraction. So we have our desired outcomes. What do you want to happen over the total possible outcomes? Remember, outcomes are all of the events that are most likely to occur or happen. There are results. Simple events are an event of that are made of exactly one outcome where all outcomes are equally likely to occur. We talked about simple events when we began to talk about sample spaces. A simple event. So we're going to go over some practice problems. So we're going to go over two problems for each type of event. So a simple event. A bag of game markers contains 4 red marbles, 5 blue marbles, 3 yellow marbles, and 3 green marbles. If Mario reaches into the bag and pulls out a game marker without looking, what is the probability that he will pull out a blue game marker? So we're going to look at if he chooses a blue game marker. Well, we need to look inside of our bag. How many events are there? 15. Well, remember if we do 4 plus 5 plus 3 plus 3, it should equal a total of 15 marbles inside the bag. Therefore, there's 15 outcomes. Where we're looking, if we find the probability when we're creating a fraction of what is going to be blue. So how many blue marbles are there? There should be a total of 5 blue marbles out of 15. Remember, whenever we are doing fractions, we always need to make sure fractions are in its lowest form. So we're going to divide this by 5 and our answer should be 1 out of 3. So out of the bag we should have an outcome of 1 out of 3 blue marbles that are chosen. Practice problem number 2. Sasha spins the spinner shown below. Sasha spins the spinner once. What is the probability she will land on E or G? Well, we're going to look at the spinner. Remember, there's 8 possible outcomes because there's 8 sections on the spinner. Now, we're going to look at what is the probability. We know we're creating a fraction of her landing on E or G. So we're just going to add E or G together because that's what we're looking for, E or G. Now, we have 2 sections with E or G out of 8. Remember, we always want our fractions in their lowest form. So we're going to reduce it. Now answer should be 1/4. So we should have a 1 out of 4 chance of getting E or G on the spinner. Compound events. Remember, compound events are 2 or more simple events placed together. So we're going to go over practice problems for compound events. So Kennedy spins the spinner below twice. What makes this a compound event? Because she's doing it 2 times. So what is the probability that the spinner will land on an odd number, both spins? Remember, probability, we're creating fractions. Well, let's look at our spinner. Well, how many outcomes is on the spinner? We should have 6 outcomes because there's 6 sections. But remember, Kennedy is going to do this twice. So she has spin number 1 and spin number 2. But she has to do this 2 times. So the first one is 6 outcomes. The second one is 6 outcomes. So 6 times 6 is going to be 36 possible outcomes that Kennedy will have. So on the first spin, she's going to get an odd number. So remember, 1 and 3 are odd numbers. 2s are evens. So we have 4 odd numbers. And we're going to do that on spin number 1. And then on spin number 2, she has 4 out of 6 as well. So she has a 4 out of 6 chance on both of the outcomes. Now, remember with fractions, in order to get the outcomes, we got to multiply 16, the numerators, and multiply the denominators. So we would have 16 over 36. Remember, we can reduce 16 over 36. We have a common factor of 4 to reduce by, and we would have 4 9s. Another way of doing this is if we can reduce 4 6s, so finding a common factor would be 2/3 times 2/3, because they're exactly the same fraction. You can also get 4 9s. This is another way of doing it. So we know that Kennedy has a 4 out of 9 chance of getting an odd number on both spins. Practice problem number 2. Laura will spin the spinner once and roll a dice number 1 through 6 once. What is the probability that both the arrow will land on a blue section and she will roll on an even number? So this makes it a compound event because she has a spinner as an event and a dice as an event. We need to find the probability of both the arrow will land on a blue section and she will roll on an even number. So let's look at our outcomes. So we're going to look at 8 outcomes because we have 8 sections on the spinner and 6 sections on the number cube. So at the end result, we should have a total of 48 possible outcomes. So let's look at our spinner and look at how many sections are blue. So we're going to look at our blue sections. So we have 3 out of 8 sections. Oh, also we have a number cube. So we have 3 out of 8 sections that are blue. And we're going to look at our number cube. How many numbers are even? Remember, on a number cube, you have 1, 2, 3, 4, 5, and 6. Remember, 3 of those numbers should be even, so 3 out of 6. Remember, we multiply 8 times 6, that should be 48. The 48 possible outcomes, 3 times 3 is 9. We multiply those numerators. We can reduce this to 3 out of 16. So different way of doing this. Remember, 3/8 is already in its lowest form, but we can reduce 3 6s. That should give us a half, because 3 divided by 3 and 6 divided by 3, that's a common factor, so it will become a half. That will give us 3/16. That's just a different way to remember to solve them. So always think smarter, not harder. So there's a 3 out of 16 chance that you would get a blue section on the spinner and an even number on the number cube. Alright, independent events. With replacement, the events are independent of each other. Probabilities do not affect one another. So we're going to talk about when we have an independent event. Remember, they are independent of each other. They do not affect one another. So we are going to make sure we replace it, whatever the problem is. So practice problem number 1. Mandy has 4 blue hats and 2 black hats in her closet. What is the probability she will pull out a blue hat, replace it, and then pull out a black hat? Well, let's look at some information. we know we're dealing with probability. We know we're getting the outcome of picking a blue hat and a black hat. So we know that this is a compound event. We know that we should have 6 outcomes because we have a total of 4 plus 2. So we should have 6 hats in our sample space. Now, what makes this compound event different is that it's going to be replaced. Now, this is what makes it a independent event because it's with replacement. We're going to put the hat back. So let's think of, well, how many blue hats are in her closet? We have a 4 out of 6 chance of getting a blue hat. Now, if I take away a blue hat, remember I just picked out a hat, but what is she going to do with that hat? Well, she has to put it back. So our second outcome, we still have a total of 6 hats. They're independent of each other. It's not affected. Now, once we put that blue hat back, she's going to have the probability of getting black hats. Now, there's 2 out of 6 chance, because she still has 6 hats in her closet. 2 out of 6 chance that she would get a black hat. When we multiply numerators, we have an 8 out of 36 chance outcome of getting a black hat, and we reduce it to 2 ninths. Now, another way to do this is we find the common factors. This is 2, this is 2, so we can get 2 out of 3 here and divide by a common factor here. That would give us a 1 out of 3 chance. So we can get the same answer just by making the fraction smaller. I always tell you to think smarter, not harder. Always try to reduce it first, the fractions first, so you do one step. It just makes it a lot easier on you. So you have a 2 out of 9 chance of getting a blue hat, putting it back, and then getting a black hat. Marissa is selecting a sports ball. She selects one at random, replaces it, and then selects another ball. What is the probability that Marissa selects a football both times? So, gotta look at our key information. We are doing probability that Marissa selects a football both times. So we know that it's going to be a compound event, so we're going to be multiplying. We know that she selects one, replaces it, and then selects another one. So let's look at this. So we got to look at how many balls are there. There's a total of 9 balls. Okay, now remember that she's getting a football. She's selecting a football. So there's 4 footballs out of 9. Now, if she gets the ball and then she decides to put it back, she still has 9 balls. So we're going to, she still has a 4 out of 9 chance of getting another football on the second selection. We multiply our numerators, 16 times 81. Now, this is already in its simplest form. We cannot simplify this any further because 4 out of 9, there are no common factors between 4 and 9, so it's already in its simplest form. So the chance that Marissa would get a football on both times is a 16 out of 81 chance that she'll get a football on both chances, on both tries. Dependent events. Now, dependent event is without replacement. The events are dependent on each other. So what happens to one event does affect the outcome of the other event. Dependent event practice problem number 1. Amelia has a bag of cookies. 2 are chocolate chip, 1 is an oatmeal cookie, and 4 are peanut butter cookies. What is the probability that Amelia would pull out a peanut butter cookie, eat it, and then pull out a chocolate chip cookie. Remember, so we're looking at what we have. So we have a probability. She's going to pull out a peanut butter cookie. Key thing, she's going to eat it and then pull out a chocolate chip cookie. Well, let's look at some information. We know there's 2 chocolate chip cookies, 1 oatmeal, and 4 peanut butter cookies, leaving us a total of 7 outcomes in the bag of cookies that Amelia has. Now, she wants to choose a peanut butter cookie first. Well, how many peanut butter cookies are there? There's 4 out of 7. Now, what is Amelia going to do? She's obviously going to eat that peanut butter cookie. So that takes out a cookie. Now leaving us not with 7 outcomes, but now leaving us with 6 outcomes because she ate one of the cookies. So she wants to now pull out a chocolate chip cookie. Well, how many chocolate chip cookies are there? 2 out of the 6. Now we follow through, multiply numerators. That's an 8 out of 42 chance. And then we reduce it, so she has a 4 out of 21 chance of getting a peanut butter cookie on the first try and then a chocolate chip cookie on the second. Now 4 out of 7 is already reduced. We can reduce 2 out of 6 by dividing by 2. That would give me a 1 out of 3 chance. And we can multiply 4 over 21 because 7 times 3 is 21. So remember, you can also do it that way as well. Alright, last problem. Our box holds a white button, a brown button, and a black button. What is the probability of picking a white button and then without replacing it picking a brown button on the second pick? So we're doing the probability of picking a white button first. She's going to do it without replacing it and then picking a brown button on the second pick. Well, the box obviously has 3 buttons. So that means we have 3 outcomes on the first pick. Now, she's getting a white button. So she has a 1 out of 3 chance of picking a white button. Now, she is not going to replace that white button. So the number of outcomes is going to change and she has 2 outcomes now. So out of the 2, how many of those are brown? She has a 1 out of 2 chance of getting a brown button. So our final answer is going to be 1 times 1 is 1, 3 times 2 is 6. She has a 1 out of 6 chance of getting a white button on the first one and then a brown on the second pick. Now class, what you're going to do is complete the strength training practice problems that I provided for you. They will cover simple, compound, independent, and dependent events. We will go over them in our Zoom meeting on Thursday, so please prepare. This will count towards your grade. You're going to turn them in using your Word document, your answers, and I will see you on Thursday.